Okay, this will be a really brief showcase of a program I wrote in Python to try and, arpeggiate something we were doing in math class. We're in my math class, we're currently looking at what happens when you take the results of a function and put it back into the function a million times. So, like, it starts here and you plug it back into itself and you get all these, wacky patterns. And I'm like, oh, can I turn that into how can I hear what that sounds like? How do I make, some audio that stays true to the thing I've generated? So I made this LFO generator that basically generates two LFOs, one for the x-axis, the other for the y-axis. You have a sample rate that chooses how often you take an x or y value. So like multiples of 2, you get, the second x value, fourth, sixth, etc. What to round to, because like these numbers are boxed in and like between 5 and -5, or at least for this graph, and all that, and a max orbit, because you'll notice that, sometimes here's a textbook. Sometimes they can get locked into loops, or they can get locked into cycles where they just get the same values. So you can set a max, so you don't just get that infinitely. And then I have a few functions at the bottom just to do useful things, like make all the values positive, or make all the values binary sequence. Now that didn't sound very good, but you can get pretty avant-garde and like experimental to super high-pitched. You can also get and this is through FoxDot. It's pretty basic. I mean, I can think about how you would add a more complex chord structure. You could have, the root default change after a certain number of after a certain amount of time. So you could have, looping 4-chord progressions. I really should have prepared some more, cool sounding functions. Oh yeah, I remember. These were to demo what it sounds like in the raw. Like, this is what a raw cycle sounds like. Multiply it up a little just because the values are, extremely small. But you can have, you can create, like, just to break down this function really quick. And I'll expand on this in the second video, because you can do some really fun stuff with this. This is going between the values of the raw LFO output. That's what I said, LFO. The raw function output. That's what I said, LFO3 to. Actually, it's not the raw. It's converted to integers. Plus this is the raw output of the x parameter, the second LFO. The duration is set to 1 over the integer value of the x value of the integer of first LFO. I mean, okay, my original draft for this video was like 10 minutes. There's a lot to explain, but I hope you get the gist of, what I wanted to create.